Hello, everyone. Welcome to 7P Speak. So if you joined last week our webinar, so welcome back. Thank you, guys. Thank you so much for making your time to join our 7P Speaks. My name is Joseph. So today, we are back with the React webinar. So last week we also already talked about the Android webinar. So today we have the very fascinating topic about the React webinar, deploying the React application with the confidence today. All right, so welcome to 7P Speak. So I just want to give you a little bit brief about 7P software. Some of you already know who we are. Some of you might the new to join here. So 7P, we are like a software design agency based in Thailand, but we are originally from Norway, and we have been in Thailand for more than 7 years already, and we are growing the team, and now we have almost 100 people in Bangkok office, and with the 22 different nationalities working together. So pretty much we have international cultures, and they're very growing fast, one of the fastest growing software and design agency in Thailand. And we always share our activities and also all of our case studies and what we have thought of about our webinars, and also discussion topics on our social media. So please kindly follow and like on our Facebook, LinkedIn, or other channel such as Twitter or IG. Yeah, so we always share our the plan for the webinars, or in the future if we got a chance to organize the meetups again, we also share the all of the activities on our channel, so you will see what we are doing. And as you all know that our team is getting bigger, we are working very hard, and of course we also party harder as well. So this is a few moments from our before pandemic, before working from home. So we enjoy, we organize a lot of party on the rooftop, going out and dining in the restaurants. Yeah, we have fun, and we did a lot of sports as well. So yeah, we have different groups in our company, such as someone who is very interested in the gymnastics, outgoing activities, running in the park, and we also some other group people love to play, e-sport in the office together with the gang after working hour, especially almost every Friday. We play different games in the office. Yeah, of course, we also have other teams badminton teams and also the running teams. Yeah, we used to have it, but for now everybody working from home due to this pandemic safety fast, right? So we urge everybody to work from home, and then we are stay connected each other. That's why we try to organize those kind of this kind of activities, webinars, for all of the people to connect with 7P software. Yeah, and also we eat hard as well. Yeah, and we have a free lunch every Thursday to try the different additional cuisines as a buffet, so you can enjoy as much as you want. Yeah, so, and also we can mingle each other in the team in the kitchen. Yeah, we really miss our office right now. We will do back as soon as possible after everybody get safe, and I wish pandemic is over soon. Yep. All right. Yeah, we also hiring. As I mentioned, we are growing the team very fast, and almost 100 people right now. And of course, we have more, the room for the new, the people to join with us. We're expanding, scaling up our teams. So right now we are opening a few positions in the cloud architect or backend, .NET, and also front end. And we also have full stack developer role, mobile, iOS, Android. For the Android, who has a specialist in the Kotlin, and we're also looking for the software a QA designers as well. Yep. We also have upcoming meetup. Oh yeah, this one, yeah, this is not a bigger one, I think. Yeah, we will also announce soon, once we have the new upcoming things. Yeah, we announce on our social media as well. So today we have the three speakers. We have the first speaker, we talk about the getting hook on the performance and then killing code. It's Denis. And second speaker is Huad. He will talk about the tips and the trick to the effectively using the React contest API. Last not least, we have our tech lead, Georgii. We will talk about the delivering React applications with the confidence. All right. So the first speaker, I just would like to invite Denis to talk about his topic, getting hooked on the performance in clean code. Denis, are you ready?
Yes, hi. I'm ready.
Hi. Great. Hi, Denis. All right. So yeah. So you'll be the first speaker. So you're ready with the presentation, right? Getting hooked on the performance and clean code. Great.
Yep. I just need to find a way to share my screen. So give me a second. Right now, it's asking to share my whole screen, which I don't really want to do.
Right. So
there we go.
Our organizer, we assign you to share the screen. Okay. Here we go. Look good. All right. Okay. So welcome, Denis. I will leave you here. Yeah.
Thank you, Joseph. That was good introduction. Yeah, the company looks really fun, and yeah, everybody really encouraged to check them out. Yep. So my name is Denis. Yep. Yeah, my name is Denis, and I'm a full stack developer. Most of the time is spent in JavaScript ecosystem, which for me is mostly React and pretty much anything that runs on Node.js. I say JavaScript, but really I use a lot of TypeScript, and I can't really imagine writing JavaScript without TypeScript, which is kind of funny. But you know, TypeScript I think is quite fundamental for a clean code base, and if you're working in a big team, I really recommend you check it out. I'm not going to go too deep into my background because I really have a lot to say in this talk, and you probably can see I'm very nervous. Sweat is falling off my head. So let's just dive into the talk. All right, so you might be thinking like performance, clean code. What am I about? Like those two things don't really mix together, right? When people talk about performance, they talk about performance, and clean code is a separate thing. But you know, I really like clean code. I really like performant apps. So I'm going to make a bold statement and say that by writing clean code, you can achieve good performance. And let's see how far I can get away with this. Yeah, so let's try. But let's define first what clean code really means. For me, it really means that the code is easy to extend, it's easy to understand, and not just for you, but actually for a new member coming to the team who's unfamiliar with the code base. He should be able to come in and be able to quickly contribute to the code base, implement new features and stuff like this. So that in terms of business value, that's what really is important when we're talking about the clean code. How can we ensure clean code? Naming is super important. I mean, imagine a code base, very well written, but with really bad names. Like everything is named foo and bar, password is named username is named password. I mean, you're not going to understand anything that is going on there, right? So naming, key. Consistency is also key. Try to do everything in a certain way, follow your patterns. Even if it's not the best way, don't do it in 10 different ways within your code base, okay? The other key is single responsibility. So if you're writing function and component, make sure that it's doing only one thing. It's not doing too much. If it's doing too much, you probably want to split that component to multiple components, okay? And then best practices. Yeah, I mean, this one is really broad. It depends on what you're doing. Find the best practices for your topic and apply them, because this will allow your team to kind of be on the same page, and it will allow you to have to follow cleaner patterns and probably even improve the performance. So let's define performance. Well, performance again is a broad topic, and in terms of React rendering, we're really interested in the fast initial render, and you want the application to be responsive to user interactions. So yep, that's because you don't want to see an application that's really sluggish, you know, every time you click a button or scroll or something like that. So for first initial render, really you probably want to use a bundler, something like Webpack or Snowpack. There are plenty of them. Choose the one you like. What they usually do, they split your code. They remove the code that you don't use. You can do something like lazy loading or dynamic require, something like this. So, but to make use of this, you really need to be splitting your components physically by yourself into different components, right? Into different files. So if you were to write an application and put it all into one component. So let's say you have an app and app component, and inside there you put a header, footer, all the content, all the UI elements. You put it all in there. The Webpack is not going to help you. It's not going to be able to split the code. So yeah, you need to think about this. So, but that's only going to help you with the first initial render. But once you render that, what you need to do is to optimize your render functions, right? So your rendering has to be fast on consequent user actions. And you also want to make sure that you're not rendering too often. Like if nothing is updating on the screen, why is it re-rendering, right? If you're only touching the header, why is the footer re-rendering, right? You wanna optimize for that. But before you optimize, you actually need to understand how it works. Why are we even talking about this? Like, is React slow? Wasn't like React supposed to be fast? And yeah, React is actually really fast. Usually in like 90% of the time, you don't need to even worry about this. React is really smart. It's doing a lot of interesting stuff behind the scenes. Like when it's rendering, it's reconciling the virtual DOM with real DOM. So yeah, it's fast. But when it is slow, there's something you can do about it. But before you can do something about it, you actually have to understand where it is slow, and you need to measure like how slow it is, right? So you probably want to make sure you have a really slow device somewhere on your hands, because if you're testing the pages with your MacBook 2021, you're not going to see slow performance most likely on most of the pages. So maybe take an older device. Not everybody has a new MacBook. But yeah, once you found out some pages slow, what can you do to find what exactly is happening there? So flame graphs, something like Chrome DevTools has a flame graph view. React DevTools also have flame graphs. What it really shows to you is like the call stack of what's being rendered and how much time it takes. So if your flame graph like it's really tall, probably a lot of things are rendering. And if you don't expect them to render in this moment, maybe you need to investigate why is grid being rendered so many times? What am I doing wrong? Do I really have to re-render it? Yeah, but if flame graph is difficult to read, you can try another thing, which is in React DevTools, there is a highlight updates checkbox. Once you mark it, try and go play with your application. Try clicking on different places, and you will see that React will highlight those elements that are actually re-rendering. So if you're, for example, clicking on a menu button in the header, and you see that something is highlighted within the body of the content, you probably need to start asking questions. Why is my body re-rendering when I'm only touching the header, right? So you can go in and investigate. And the other cool thing you can use, and this one is really more like low level. So it's a component coming from React. It's called Profiler. So you can wrap any component within the profiler and attach a callback, and it will give you some stats, how fast it's rendering, how many seconds it took, and so on. You can really incorporate this into your build tool and maybe generate some kind of automated reports every time you push to CI/CD. And so later you can analyze, okay, was there an improvement or maybe there wasn't? Right. So now once you've identified, okay, I have a problem on this page, looks like a problem, but I don't know why the problem is there. What did I do wrong, right? And to answer this question, you really need to understand why does React re-render something? And it's actually very simple. There are two rules you need to remember. React will re-render your component when state inside of it has changed. And the other reason it can re-render is when the parent of that component has re-rendered. So when, let's say in this slide, when component is getting re-rendered, React will actually go into every child of that component and re-render that child, and then go into child of that component, all the children, and re-render all the children. So if you were to re-render like at the very top of your React tree, it will actually affect all the components down to the last node. So it will have a big effect on the performance. So you want to optimize for re-renders at the very top, right? You don't want it to re-render the top of your tree too often. So what happens when React actually re-renders, right? What is the process? So the first thing, if you're using function components, which probably you are already, right? You should. If you don't, then you should. So the first thing that happens, it will run your render function. It will run it all the time, every time. Okay. If you have something like useState, useEffect, useCallback, anything you have inside your component function, it will run every single time. If you didn't know, your beautiful JSX is actually compiled down to just React create element calls. So although those calls are really fast, they're really efficient, they still have some overhead. So if you have like 10 components on your page and they render so many times, not a problem. But if you have like 1,000 components and they render so often, it's going to have an effect. It's going to have performance costs. So this is when you need to optimize. So once it has generated, it has run your render function, it will generate the virtual DOM. You can see it on the left side. So maybe during this render function run, it has added a new element on the left, which is in green, and it has modified an existing element, which is in brown. So React uses virtual DOM, and once it has compiled the virtual DOM, it will apply the updates to the real DOM. So it will compare the virtual DOM with the real DOM and only update the parts that have changed. So why is it doing it using the virtual DOM? Because virtual DOM is like really cheap, really fast to update, while real DOM is really expensive, really slow to update. So it's trying to minimize the number of updates that it has to do. All right. So we now kind of understand when and why React will re-render. So let's look at some examples. Let's look at this component. This component has no state. It has a count and a button, right? Every time we click the button, it will increment the count. But you might have noticed that count is actually just a JavaScript variable. It's not connected to React state. So no matter how many times you're going to click this button, the count is not going to change on the screen. You will always see 0. Although the count in JavaScript code, yes, it's going to increment, but your component is not going to render. Why? Because the state did not change, right? Okay, so let's kind of fix it. We want to see the count, and let's put count into React state. So every time we click on the count ++, we are going to set count, change the state. And when we change the state, what happens? The component will re-render, right? Okay, simple, I guess. All right, let's look at a more complicated example. In here, we have a menu. Right under the menu, we have a toggle menu button. So when you click that button, the menu is going to be visible. When you click on it again, it's going to hide, right? Right under there, we have a page. And imagine that the page is like a really big component, like a lot of children in there. It's expensive to render it, right? So question, when you click the toggle menu button, will the page re-render? And to answer this question, you have to go back to those basic rules. The component will re-render when we change the state. Do we change the state here when we toggle the menu? Yes, we change the state of app component. Now, the second question we need to answer, or rather use the second rule we need to use, is that every time the parent renders, it will re-render all of its children. So when app re-renders, the page component will re-render as well. Even though page component has not changed, nothing has changed inside there. Even if page component is really expensive to render, it's still going to re-render, right? So this seems like a problem, and I want to say that we can use clean code patterns to fix this. So let's try to fix this. But before we go to clean code pattern, there's actually a thing you can do to optimize this using just a performance optimization, which is called, done with React Memo. So the way React Memo works is going to cache the render function of the output of your render function. And next time that the page needs to be rendered, if no properties has changed to the page, then it's just going to use the cached version and not going to run the render function again. But like I said, this is a performance optimization. It's not a clean code pattern. And we want to start with a clean code pattern. So to clean up our code, I'm going to move the button to toggle the menu inside the menu actually, right? Because if you think about it, why does the app need to know how to toggle the menu? It's the responsibility of the menu. The app responsibility is just to compose those elements. So think about single responsibility, okay? here, what happens is that when we click the button in the menu, right, the toggle menu button, it's going to mutate the state of the menu component. So the menu component is going to re-render. Yes, that's okay. But if we look at the app component, nothing, no state has changed inside the app component. So if no state has changed, the component is not going to re-render. It does not have any parent, so it's also not going to re-render. So the page is not rendered again, and everything is good. We have optimized for performance. So just by cleaning up our code a little bit, using the single responsibility pattern, we've improved performance dramatically. This is a very simple example, but if you take it further, if you use just this pattern on different levels of your application, you can dramatically increase the performance. Okay. But you might be asking now, okay, Denis, that was a very simple example. Sometimes I need to actually share my state between different components, right? So what do? The answer is you need global state, right? And let's take a look at this example. So in here, it's not really global state. It's still kind of local, but we're passing down the state down using the props. So what do we need here? We basically need to show menu and with a username that we fetch from the API, right? And the page, it also needs access to the username. And we're also going to pass the username down to the page. However, the page itself does not need the username at every component. It really only needs the username down at the very low level at the component name bar. So if we look at our React tree, we need username in menu and we need username at bar. However, with this implementation, when we update the username, everything within the menu and within the page is going to update. So your whole React app is going to re-render, which is going to be really slow. What do we do? How do we solve this, right? Well, the option is you need proper global state management. And there are many solutions. You can find a lot of NPM libraries. So Redux, everybody knows Redux probably. Most of you maybe like it, maybe hate it. I don't know. It's your decision. But Redux for me is, you can say it's a clean code pattern because it forces you to stay consistent within the patterns that they define, right? It has a very strict structure, sort of to say. So if it works for your team, good. Me personally, I'm not a big fan. You've got other options, which is Context API, but our next speaker, Huad, is going to go deep into that, and he's going to explain how it works. So I'm not going to touch on that too much. For me personally, I tried Zustand. It's an amazing library. It's maintained by a guy named Daishi Kato, I think. Check him out. He's really good. There's other new kind of libraries like Jotai and Recoil. Recoil is from Facebook, it's experimental. Jotai is very similar to Recoil, but it has a better API. It's simpler API. It's based on atoms, so yeah. But yeah, let's take a look at Zustand. So how can we actually improve the previous example performance with something like Zustand, right? So if you remember, previously we were creating the state inside the app component, right? And we were passing it down to menu and to the page. And every time username updates, everything is re-rendered. Okay, what we really need to do is we want to kind of we want to access that state only in the component that really needs it. And the component that really needs it is menu and bar. So with Zustand, what we can do is we can create a store, and the store is going to be like in some other file. And the store itself is going to contain the state, and it's going to contain some functions, how you can update that state. So you probably already see that this code is much cleaner. We have removed the concept of fetching the user away from the app and into the store, right? So because apps shouldn't really be responsible for fetching the user, it's really kind of some other concern. So think about simple responsibility again. The cool thing with Zustand is that you can subscribe to the portion of the state. So in this store, we have username and we have access token, but the bar component really only needs username. So we use a function called useUserStore, which is coming from Zustand, and we subscribe just to the username. If access token updates gets updated in the user store, the bar component is not going to render. Only is going to re-render only when the username is updated. So this is kind of similar to Context API, but it's an improvement on it. So check it out. It's really cool. And by the way, it's really, really small. It's tiny. All this amazing stuff in under 1 kilobyte. If you don't want to move away from Context API, I advise you maybe check this use context selector. It's tiny. You can pretty much use the same API as you did with Context API. So you create a context as usual, and then you can subscribe just to the portion of that context. So you say, I need user context. And from there, I only need username. So the bar is going to update only when that portion of context has changed. And this is kind of solves the whole Context API performance problems. Yeah, check out Daishikato, amazing guy. He's doing maintaining quite a few libraries around state in React. So yeah, don't forget to send love to Dan. Yeah, so what's the other performance issues we can come up in React? List is a big one, and you really have to understand kind of how React renders. And if we go back to the things we described, the way React renders, what we want to focus on, let's take an example where we have a list of, let's say, friends, right? An array of things. And inside there, we have hundreds of items, and we all rendering them through map, right? And we want to add a new item to the beginning of that list. So what will happen is that React will see that every item after the item that we have added has changed when it compares the virtual DOM to the real DOM. It looks like every item has changed, right? So it will actually try to update every single item. So it's going to be like 100 items going to be updated. It's going to be really slow. But actually, we know that those items haven't really been updated, right? What really happened is we just only added one at the top. And to help React with this, we need to add a key, a unique key to each item. So instead of having React reconcile using the index of the item within the list, right? It's going to reconcile using the unique key. So it's going to say, okay, I've seen this guy before. It has this unique key. I'm not going to update him. He's the same. Good. But is this coming from performance optimization? Is it coming from clean code? Yeah, it's kind of performance optimization, but I would kind of say that if you're writing clean code, you're probably using a linter, right? Linters usually allow you to follow the good patterns. So if you're using the linter, most of the linters will suggest you to add the key. So yeah, we're going off on a tangent a little bit here, but yeah, use a linter and add keys to your div, to your lists. But sometimes even the keys will not help you with when you have like really long lists. Like let's say you're trying to render like 1,000 rows inside a table, right? You have maybe infinite scroll or something like this. Yeah, you have a problem here. You can either solve it by using pagination, but when you're saying, okay, I'm going to do pagination, then you're kind of limiting yourself in design choices that you have, right? Okay, so what else can we do? Well, really, the only thing you can do is virtualization, because even if your components, your list components are really, really well optimized, like the render functions are running really fast, if you're running like 1,000 or 10,000 of them, it's still going to be slow. Yes, each of them is really fast, but when you have 10,000, it's going to be slow. So you need to virtualize them, and virtualization really means that you're only going to render the components that you are showing in the current view. So if the user can see only 50 items within his screen, you're only going to render them, right? And the rest of them that are at the top, at the bottom, that are hidden away from the view, are not going to be rendered, and they're going to be rendered as soon as they appear in the view. So you can actually implement this by yourself, but it might take some time. So maybe use a library like React Virtualize, and it's really cool, yeah. But if you have like maybe a really, really tall screen, that will not help you too. If your screen can show like 10,000 items, then even this will not help. But yeah. So what other optimizations can we do? Well, there actually are quite a few more we can do, but they're not kind of based on clean code. And they're, to tell you the truth, they're not that important. If you were to follow all the recommendations from the previous slides, 99% of, okay, let's say 95% of the time, you would be quite okay. But when you do need to optimize a little bit more, you have stuff like use memo, use callback, and others. So use memo is something you would use when you want to make sure your render is running quickly, specific render function is running quickly. So let's say you have maybe some computations that you are doing within the render function, and it's really expensive, and you only want to do it maybe once or when something changes. Yeah, you can use memo, but don't forget that don't do use memo for everything. Don't use callback for everything, you go, okay? Because they have actually their own performance overhead. And if you're not seeing any slowdown, maybe just, don't use them if you don't have a good reason. I guess, yeah, that's it. So thank you. And I hope you learned quite a few tips and tricks. And when you come back and apply those optimizations, I'm sure your dirty code will become cleaner. Thanks. I guess now we can ask some questions. So go ahead and ask your questions. I'm going to give you some time, and yeah.
Thank you, Denis. Very interesting topic you shared it. All right, so everybody, you can ask any questions to Denis. So you can ask in the question box. You can type it here so Denis can answer. So, but I see the one question which is general things. Will recording of this presentation be available afterwards? Yes, of course. Like we uploaded a week later. So next week it will be available. We will share this on our social media. So this week we're gonna upload our last week webinar for Android. So this React webinar will be recorded and uploaded will be in next week. Yeah. So if you have any questions, yeah, feel free to ask Denis.
So I see one question here. So Nick P asking, okay. Is there ever a situation where you need to write ugly code because it's the only way to get good performance? Yeah, I think, yeah, absolutely. Sometimes you do need to write ugly code. And I would say something like use memo, use callback, use ref, React memo is ugly code. It doesn't look good. It doesn't kind of convey your business value, what you want to present, but it does optimize the performance. So anything that does not come with just like natural kind of clean code pattern would be kind of ugly code, right? Because in a perfect world, I wouldn't want to write use memo, right? I wouldn't want to write use callback, right? But I would want to split my components. I would want to make sure my functions have single responsibility, right? So that's the answer, I guess. Any more questions? Let's see. Yeah, like I said, our next talk is going to be by Huad, who is going to dive deep into context API. Hopefully, he's going to give you some tricks and tips also how to optimize it.
All right, so yeah, if we don't have any more questions, so Denis, thank you so much. So I'm gonna invite Huad. He's gonna talk about the tips and tricks to effectively using the React Context API. Welcome, Huad. Thank you, Denis. Yeah.
Thank you.
All right, so Huad, yep, are you ready? You muted? Okay, cool. Can you unmute it?
Oh, sorry. Okay. Can you hear me now?
Yes, we can hear you.
Yeah. Okay. Okay, so for this topic, I'm gonna go a little bit deeper for React context. I guess Denis have a good presentation about the React performance in general, and he touched a little bit on context. So maybe I'll give a little more explanation on context here. Let me introduce myself a little bit. My name is Georgii or Huad. I'm full stack developer at 7Peak, and let's get started. So today, for a topic about React context, I'll give you a little bit introduction and APIs, and I'll go dive deeper a little bit with an example and give you some tips what you should do and what you shouldn't do, and a little more example in real world use case. So let's start with the first part. Let's introduce you some context. So in a typical React application data, no, I'm just kidding. So nobody's like this long text presentation. So let's get rid of everything. Now it's better. So brief introduction from React documentation itself. It says the context provides a way to pass data through the component tree without having to pass down manually at every level. But I can simply put as the context API is just another way that allowing you to implicitly share data or states between components. So maybe that doesn't give you much of the details. So maybe we do some example along the way, and hopefully you get the idea. So as I mentioned, the context is for state or data sharing, right? But fundamentally, in React, data sharing is just passing prop. So what's the problem, and why do you need context? You can simply just passing prop. But the problem will arise once you have to pass down multiple levels, as Denis have some example before. It's called prop dueling. It's happened when you have to pass down your data or prop into multiple level, and the intermediate component, it doesn't have to know about this data. So it's quite cumbersome and annoying. So then if you're the one that say, I'm okay with that, so what's the problem? So I just need to write some more code, right? But it comes with some problem that you might not know. As the condition of rendering of the React, that when every prop changed, the component has to re-render, and this intermediate component doesn't have to know and doesn't use this data, but it has to re-render. So a little more example, everything in between got re-render, as you can see on this screen. And this is just I just record the video on my screen and put it in the GIF. The flashing border you can see here is coming from the React developer tool itself, like Denis showed before. So you can play around and you see a similar result as I present here. So this is the problem that the prop dueling gives you. So now we can solve this issue with context. With the context API, the first thing we import a function called createContext from React, and it takes only one parameter, which is the default value. But I will just put undefined here, or if you use TypeScript, that you know that you have to pass this, because in the React source code it marked as required prop. So, but if you use JavaScript, you just leave it there. You don't have to pass anything. I'll go back to this default value later on. So when calling createContext, in return you get a context instance object, and then you have context and how to use it, right? So in the result of calling createContext, you get the context object instance, and then in the instance property you have a component called provider. So you just need to create the component with the one required prop, which is value. This value will be using when you consume the context. You just create a component and wrap it everything inside. So when consuming the context, you just use another hook from React called useContext and pass the context instance. In return, it gives you the value that you just passed in the provider before, which is the object that contains current color and set color. When using it, you just access the object like so. So in this example, the component will use the set color in the on-click event handler button. And another one, you just consume the color from the color context object like this. Yeah, that's it. So if you can see, all the component in between doesn't re-render, and it doesn't need to know this color. Only color component that consume it. So the way it's worked, that every time the value in provider component change, every component that's called useContext will subscribe to the value, and every time it's changed, it will reflect the change to the consumer component. And that's pretty much the basic idea of context. But I think it might be good that I show you some more interesting use case, and I'll show you some more complex example later. Like before we wrapped everything inside the context provider, and as you might remember, the grandparent component has everything inside, including the color component, which is the context consumer. So what happens if you render consumer outside the provider? The app will break at runtime. So you get this error saying it's cannot access undefined. So what is this coming from? Basically, when you consume the context, you try to access the value prop that you sent in the provider, but if you consume a context outside the provider, it won't be able to know what the value, and it will fall back to this default value when you create the context. And at the time I create the context, I give the default value that is undefined. So if you have some default value provide here, it will use this value. But most of the time you won't or you shouldn't, I guess, provide this default value, because it doesn't make any sense to use the context at the first place. So you shouldn't render or consume the context outside provider. Now, we can make our life easier when we see the error before. It doesn't help much and it doesn't give meaningful meaning. We can provide our nice custom error message when we consume context, like here. We check if the value is undefined or falsy, then it's implicitly mean that we consume this outside of the provider. So we can throw our own custom error message like this. And to get the code more cleaner, we can abstract the provider component and we can use it without any extra code, and implement the detail of the provider itself. To abstract the use context itself, we can use we can create our custom hook and consume it easily like this. So this is the example to get to use the context in fundamentally way. But let's do some more complex example, and we can now see the more problem if you use it incorrectly. So let's give the app a little more interesting. So now we have some simple drawing app which have some header, main layout, and will render the result of the nice painting app on the left. And on the right, we kind of have like an editor module that we can select the shape, the color, and the preview shape or color itself. For the code structure with context, we can provide here. We can see that our app needs two things, which is the shape and color, and we give us the provider for values, which is two getters and two setters here, and we abstract the consumer into custom hook called use paint. To use it, we wrap everything inside the provider, and for the single component itself, the preview of the result, we consume both shape and color. And for paint, we show the result in shape preview and color preview. And to select the shape and color, we consume it in the shape selection and color selection, like so. Now let's see the result. So the rendering result is quite good, right? So the main layout, left panel, and everything in between doesn't have to re-render unnecessary. But did you notice something that's quite isn't right? Yeah, the header itself, it doesn't have to know about the color or shape. So why it's re-rendered? That's because we wrap everything, including the header, inside the provider, but it doesn't have to. So first tip, you shouldn't, and you shouldn't always put the provider at the root level. You have to wrap it closest to where it's needed, which is main layout here. Or you can go even further down if the use case you only need in the small tree down the component. Now it's much better, but there's some problem still. As you can notice here, when you change a shape, it doesn't have to do anything with the color itself. So I guess we can do better in terms of rendering optimization here. So in some sense, this color and shape, it's two, you can say that it's two different things. So you it shouldn't be in the same place. So I guess we can break it into two contexts here. Like this. So one is shape provider and color provider. So the main takeaway here is you shouldn't put everything as a global state if it's not have anything to do with each other. So you can separate in smaller related groups or state like here. So now we have color context and shape context. And to use it, you can use it from the provider directly, or you can abstract a little bit to get a little cleaner code in one provider like this. And to consume it, before we have consumed the shape and color in paint preview from the one context. Now we just need to consume it from different contexts, and the other part only have to consume from the related context, like shape only consume it from shape context, and color only consume it from color context. Now that's better, right? So every time you change the shape, it's only have to re-render the final preview and the shape preview itself. Same thing with the color. But as you look closer, you can also you can still see that there's unnecessary re-render here in the shape selection or color selection. It's only render 3 buttons, and when you change it, the UI doesn't have to change. Then it shouldn't re-render, right? Now, if you can think of other method to prevent re-render or optimize some re-render, you may be think of React Memo. So yeah, let's try that. So you can wrap React Memo. You can wrap selection with the React Memo. So everything should be good, right? No, why it's still re-rendering? Because React memo says that if the prop or state doesn't change, it doesn't have to re-render, right? Why it's the shape selection doesn't even take any prop, so why it's still re-render? The reason that React memo doesn't work here because the way React design for context consumer itself, every consumer will force to re-render to keep the state consistency. So you cannot get away with React memo here. But we might have some solution to that with the React context itself. So as you can see that preview and selection component only consume one part of the context value. The preview only consume the current shape value, and the color preview, I highlighted wrong here, but you see down here, the shape selection only consume the set current shape part of the value, but it's all consume the same context. So every time the current shape change in the context value, it will force every consumer to re-render, which is the shape selection that's consume the context, but it doesn't need the value. So we can see here that it's kind of interrelated logic, but we use only one in another. So we don't have to use every value everywhere. So I introduce you the concept of context splitting. Here, before we have one shape provider or one shape context, now we can split it to two contexts. One is responsible for passing down the getter or the value itself, or another one is responsible to passing down the setter. And yeah, so we can create two contexts and wrap it together like this. And to consume it, you just consume it separately. Then I will show you in the next slide. But let's slow down a bit. As you can see that we wrap everything inside use memo here before we pass down to the provider. The reason that we have to wrap everything in use memo here, because if we pass down the value as an object, every time the state here change, it will re-render the provider shape provider component and resulting in the object to be the new reference every re-render. And even though the shape or the set current shape function doesn't change itself, but the object that passing down as a value always gets the new reference. So we use memo in order to get stable reference when it doesn't have to change. So when we want to use it, we only have to call it separately. And yeah, like in this example, so everything nice and give some performance that it doesn't have to re-render unnecessary. One more tips here is when you create context and you open in the dev tool, it doesn't have any name, so maybe you can provide some name to it and you can debug it a little easier. That's it for tips. And for example or use case for context that you might come across, it's kind of global state, like theme provider and locale provider is a good use case here. Another use case would be if you want to create some kind of reusable compile component, you can create with context. It will give you a cleaner way of using this component. Like I'll give you a brief example of one component, which is a collapsible component. The component is used like some, you can have a label, and then if you click a label, it will expand, and if you click again, it will collapse. So you can use the technique that I mentioned before, which is context splitting, and then that you can have the consumer component in the inside the panel here that they share the state implicitly. So the panel details will know when to show and when to hide when you click the panel label. Yeah, and then it's flexible in the way that you can put anything else inside or aside the component itself, so it doesn't break. Yeah, that's pretty much what we have today. In brief, we introduced the API, why it's needed, when to use it, and what we have in terms of the API and capability. And we dive a little deeper and give some tips on what to do and what to shouldn't do, and some optimization tips, and give a little bit of example. Yeah, that's it from me. Now we can answer some question. Do we have any question here? Okay. So far, I don't see any questions coming in. Maybe we'll wait a little bit more. Okay, so it's looks good so far. We don't have any question. Now I think we can wrap it for my session, and hope you learn a thing or two here. Thank you for listening. Yeah, we can go to the next session with Georgii.
All right. So yeah, sorry for technical error. So our last speaker, Georgii, is not least. So Georgii, he gonna talk about the delivery, the React app with the confidence. So Georgii, are you ready?
Okay. Hello.
Okay, cool. All right.
Great. So yeah, my name is Georgii. I will talk a little bit today about how delivering React application with peace in our mind. Let's start. So yeah, what we are expecting when we make our release, when we deliver application. So obviously, new features which we are releasing should work as expected. Should not be any new bugs, and we should not break anything that we write before. So there is no regression. How we can read this easily? It's not an easy task, but it can be. We can come to it with testing. There is a lot of speaking about testing, a lot of opinion about testing. So I would say here why we should write tests in our front-end application. See here, clients not happy if they see bugs in final product. Also refactoring, if you need to refactoring, especially some big part of code, it's always painful. It's always, you always worry about, oh, I might break something. Regressions in product which are already in production can have very high costs. So something broken, some payment or something can be really costly. So most obviously, test and save money and time. At the end, I listen many times from people that, oh, I don't have time to write tests. Maybe it's not great approach. I think it's not great approach. Because at the end, it's all agile cycles. It will save your time, obviously. And for company, it will obviously save the money. So yeah, most standard techniques, methodology to write in tests is testing per pyramid. What is this? It's basically on the base, our fundament, our basement of our pyramid is unit tests. Why it's basement? It's mean all other tests is based on this one, and it's you need to write it a lot. It's can run very fast, and you can write it actually very fast as well. Next go integration tests. It's more about how how part of your application is connected together, how it works everything together. It's a little bit more slow to run, so you might not be happy to run it in your local machine. Oh, sorry. And on the top, we have end-to-end testing. End-to-end test basically test from the beginning with the real user cases. This methodology, it's mostly can easily applicable for the backend. Because unit test, basically, if you do especially TDD, it's must. I mean, like you write in unit test before you write in the code. Integration test, you write a little bit less, but you just check how, let's say, API works. Just call API and see is it respond correctly. And end-to-end, it's mostly like Postman or something like this. You call real API and see with real data what's going on. But in backend, you not really write much end-to-end tests. But each type of this testing get his own benefits. As I said, unit test, it solves simple problems, simple issues. And without unit test, you cannot write TDD. It's almost impossible. And very painful, actually, if you only TDD only with integration tests. So integration, it's like provides reasonable guarantees that everything works as expected. And end-to-end, it's basically verified real user experience at the end. As I said, this testing pyramid very nice for backend, but for frontend, it's, I think, different way. It's frontend, we not really need much unit tests. We not really write a lot of end-to-end tests, but we mostly write in integration tests. So let's go to our testing trophy by Cant. So basically, on the basement on our trophy, it's static checks tests. Next go unit tests, big part integration tests, on the top end-to-end tests. So what is static checks tests here? Basically, it's TypeScript. So because we have JavaScript, it's basically some kind of tests that can be run without running actual code. So it's ESLint, like other linters, it's TypeScript. If you hate TypeScript, I don't know why, it's flow type. So as well, apply statical type check to JavaScript. And it's basement, actually. Without this, it's very painful to write modern, even front-end code. After that, going unit tests. Again, it's very rare situation where you actually need to write unit tests for the front end. But it will be, there is some examples I can show you later that actually unit tests can be useful in the front end as well. Integration tests, here, very big part. Yes, this is true. In the front end, we mostly need to write like kind of UI integration tests. And it's very, very important. It's become most important part here on the front end. And end-to-end tests. Like before, like let's say like 3 years ago, 4 years ago, mostly these tests are done by QA. It's very nice. Like in 7pix, we have very strong QA team, and yeah, you can put everything on their hands with this end-to-end. But not all companies have like this. And now, actually, with modern tools, we have very easy way to write end-to-end tests to our front-end application. And I will show you a simple example later. So what's tools for use our nice test? As I said, static test is TypeScript, ESLint, Flow. If you want, it's what we actually use. Flow, we don't really much use. We use TypeScript and ESLint. Unit test, Jest. I think Jest is most powerful library for JavaScript, not for only for React, but even for Node.js, even for all JavaScript and TypeScript code. I think it's most powerful unit test runner. Integration test is Jest plus React testing library. React testing library has become kind of standard already in React world. Before we used Enzyme, and some people still using it, but I think React testing library, if you try it, you forgot about Enzyme for sure. And for end-to-end tests, we have Cypress for the TypeScript, and for the JavaScript. It's a very nice tool and very easy to write tests with it. Okay. So now what I'm going to do, I'm going to show you some code. How it's look like tests. So first, it's a unit test, very rare. So what is unit test about? It's basically testing function. So let me give you some brief about what is this. It's basically a component that will show we pass the duration in the millisecond, and it get kind of 1 second ago, 25 seconds ago, like 1 hour ago, 6 days ago, 1 week ago, something like this. Instead of create tests, more integration tests, instead of run every time like use React testing library to render it with different values, I just extract this to the function, this formatting. It's not simple, it's complex function. And basically inside this test, I just run it, and it's extremely fast. It's just much faster than, so this example, you see, like, I don't know, many use cases, can write a lot of use cases. In this example, I actually use TDD practice. So with this unit test, because they're so fast to run, you can easily apply TDD even on front end. So, and you see it's isolated. It's very simple to write. It's just you call some parameter and see what's the result. And see if the result not correct, you just go back and say, oh, and fix it here. Integration tests. Integration tests. It's much more here. So here we use React testing library for rendering our password field. So what's password field? It's basically simple password field, but with some button that show and hide your password. So what we're testing here, that is a simple logic. By default, we render it, and by default, type is password. After that, we render it and click here. Click this toggle password visibility button. It's become text. And last one, we go in this password field and click 2 times, basically, and it's turned back to password again. So again, here, it's, as you see, every use case is isolated from each other. But we use rendering, we use several components. So inside this component, it's several. We use actual rendering and actual clicking on some 2 actions. So it's more like, well, integration or UI test or something like this. That's how I call it. It's not, also you can write this kind of test on the top level if you like. For example, if you have some page, there is a lot of components in it, and you need to check how these components works with together. When, for example, in previous example, when you press button, it will show should change the color. And it's 2 different components, but you write test on the top level. It's as well very easy to write with React testing library, and please write this kind of tests. And last one, this integration, end-to-end test with Cypress. So Cypress is a very great tool and very user-friendly tool, I would say. It's good documented. It's very easy to write tests and very, I would say, developer-oriented. So here, what you can test here, you can test responsive. The most important, I mean, most thing I use in real project is to check responsive design. Because in Cypress, what it do actually inside, it's open actual browser and do actual things with this browser. So in this example, it's login screen. So we open browser here, it's loads, set viewport size of browser, after that check if redirection, go to field, fill some data, and after that go to other field, enter some data, invalid password, and yeah, this one is exception. Actually, all of this in Cypress have exceptions. So here, if you cannot get input type email, it will raise an error. Here we check that error message is visible. Here we go password, put correct password, and should open home page after we put correct password. So what's the main difference here? As you see, it's very, very similar as this one, as this. It's very similar. It's describe it, everything. Biggest different from the integration test, and that it is not isolated. So all these test cases run in one page, one by one. So it's not reset like here. We see every time we basically reset the old state. We didn't every time we render new component. Here it's not like this. We visit one page and we follow after that follow instruction, follow step by step some stuff. So yeah, sometimes it can be useful and it's a little bit more costly to run as integration test, but sometimes much easier to write this kind of test in this way. Because we can, like in this example, we can actually write same stuff as in integration test in the page, but here as well, it's kind of simple to run and it's kind of makes sense. Also very important here that you can make sure that there is no regression. So here you test without any isolation. You test real site, real product. So it's very nice tool to make sure there is no regression mostly. And also it's you make sure that it works as expected. Instead of open it, just click there, just take some size. You can do everything here. You can just set up, okay, now I want a mobile phone, set viewport as this size and check, is it visible? Is it correct? Is it showing incorrect? Is it everything good? So yeah. Yeah. It's basically it. That's all that I want to say. And now I would like to listen to your questions. If there is any questions, I would love to answer it. Okay. I can see one question from Denis. Yes, we can run it in CI. So in Cypress, there is a way to run it headless. So it's use Chromium engine. It actually can use different type of browser engine inside the Cypress, but we can run it inside the CI with headless mode. So it's not really open real browser. It just run it inside how's that in memory this fake browser. To be honest, I'm not fan to apply an end-to-end test to the pipeline. To be honest, it's like yeah, because in the pipeline it must be deployed, and after that you run tests. So it's kind of little bit useless to run it inside the pipeline. I feel like this because it's run against real site. Or inside your pipeline, you need to run this in somewhere inside the Docker container and somehow, and test against it, and after the deploy, and it's too hard, I think. It's too complex. Any more questions? Okay. All right, guys, let's finish our meetup. It's nice that you come. Nice that you listen. It's happy that see you here. I hope you will come next time in our next meetups. And I hope soon I can see your faces in our real meetup in our office. Yeah, thank you.
Just to add, everyone, we will send out a survey to your email. So if you guys can fill out the survey after this meetup, that will be really great to make our meetup better in the future. And once again, thank you for coming tonight.